This is going to deal with limiting an excess amount. So we're going to start with the reaction. Just going to mute everyone. If anyone wants to ask anything, obviously you're welcome to unmute yourself. So your heading can be limiting and excess inside the mole section. Okay, so we're going to start with a reaction where I'm going to give you the amounts of something. I'm going to do a full one together with you, and then I'm going to give you one to do by yourself. So let's say N2 plus H2 gives you NH3. Okay, like any mole ratio sort of question, I'm going to split my page in columns so I can work on columns, and you're obviously welcome to do this in an exam even. I'm not just doing it here. Then I'm going to tell, okay, so let's start with just a basic one. So when I balance these, okay, I get a 3 here, a 1 here, and a 2 here. In fact, let's write that in color. Now, I know if I balance that, that tells me the mole ratio in which these elements react with each other. So 1 mole of nitrogen will react with 3 moles of hydrogen and give me 2 moles of ammonia. Now, if I wanted to give you amounts, I don't have to give you 1, 3, and it forms 2. I could give you, I don't know, 10 mole of this, and it'll react with 30 moles of this, and it will give you 20 mole of the product. As long as it's following the ratio, it's absolutely fine. You could double it, you could times it by 10, you can times it by 100, it really doesn't matter. Now, what we're going to start doing now is I am going to start giving you an incorrect amount of something. So let's look at this ratio, for example. So for example, instead of me giving you 10 moles and 30 moles, I might give you, let's say, 40 moles here. And I ask you the question, work out how much product forms. Now, because I just wrote down the correct amount, it's quite easy to see what's incorrect, right? This one. Because if I have 10 moles here, then I need 30 moles of this. And I've got 10, but 40 moles. So this section is going to start dealing with me giving you the incorrect amount of something. So you can see here this ratio is all wrong. I can't have 10 moles here and 40 moles here. So what I do then is I write down, I like to draw a line for myself, and I like to draw and say, okay, at the top, this is what I'm given. Okay, so I label it given and I draw a line there. And then I draw, and then I write how much do I need. Okay, so the top row is how much I'm given, and the bottom row is how much I need. Sorry, this one's given. Now, I mean, we all know, because I wrote the correct amounts to initially, we all know that if I was given 10 moles of this, I need 30 moles of this, according to the ratio. Okay, now let's say I wasn't given that and I had to figure it out. Then I'll go, okay, let me work out how much I need based on this. So I go 10 moles of this, divided by 1 times by 3. Oh, I need 30 mole of H2. So I was given the incorrect amount of H2. Now, then you compare the two with each other and you say, okay, look, I was given 40 moles and I only need 30 moles. So I was clearly given too much of that substance. And there's a special name for that. It's called an excess. You were given an excess of the hydrogen. So when I give you incorrect amounts, you have to figure out which one is incorrect and then label it. Now, if this one's the excess, this one's called the limiting reagent. And I'll explain why. Reagent's just a different word of just a different version of the word reactant. Okay, so we say limiting reagent. Now let's work backwards for a second because I want to explain that term. So if you said, okay, let's say I had 40 moles of this. So 40 mole divided by 3 times by 1. So always divide by the one you're with times by the one you're going to. Okay, so 40 divided by the 3. Okay, so 40 divided by the 3 gives me 13.33. I'm just going to round off to 2 decimal places. Mole of the N2. Now let's compare that as well. If I said, okay, I have 40 moles here, how many moles do I need of the N2? Well, I was given 10 moles, but I need 13.33. So I was given too little of that substance. And you called that one the limiting reagent. So you've got two things here. You've got one that's an excess and one that's the limiting. The incorrect one is the excess. If you give me too much of a substance, then some of it's going to go to waste. Now they're asking you to work out how much product you form here. Now the question is, what must I use? Must I use the limiting amount or must I use the excess amount? So I'm just going to use a little analogy to explain this. So let's say you go home tonight and you want to make cupcakes, okay? And your recipe makes 12 cupcakes. And that recipe needs 1 cup of flour, it needs 1 cup of milk, and it needs 12 eggs, and then and whatever else, and then you'll make 12 cupcakes. And you get home tonight and you realize, heck, I don't have all those ingredients. I only have 6 eggs. I have everything else, but I only have 6 eggs. So I have 6 eggs. I still have my cup of flour. I still have my cup of milk. But then you have to say, okay, well now obviously you have to adjust the recipe. If I add everything else perfectly the way it was for the 12 cupcakes, it's going to flop. So now I can only use half a cup of milk and half a cup of flour, and then my recipe will work, but then I'll only make 6 cupcakes. So I had to adjust everything according to the eggs. I had to adjust everything according to my limiting reagent. Okay? The thing that you have too little of is ultimately the thing that's going to affect how much product you make. It's not the thing that you have too much of. Half of that's going to go to waste. Obviously, in a recipe, if you kept adding the milk, the full cup of milk and the full cup of flour, you'd mess up the recipe. So in a reaction, you don't mess up the reaction. It just goes to waste. It gets left over at the end of the reaction. So it would be silly for me to add 40 moles here, if in reality I only need 30 moles. So 10 moles of H2 are just going to get left over in the container at the end of the reaction. So it's just wasteful. Okay, it doesn't mess up the reaction like it would in a recipe. Okay, so the important thing there is the amount of product you form is based on your limiting reagent. So if I were you, I'd take a highlighter in the section definitely, and I would highlight the limiting reagent and the amount that is given. Highlight the limiting reagent that is given. Okay, so you know that's the one I have to work with. That's the one I'm going to work with to figure out my amount of product. Okay, so let's erase this little cupcake one. Okay, so this one is incorrect. Then I'm definitely going to work with the limiting one. So we go 10 mole divided by, and you can use lots of colors in the section to help yourself figure everything out, divided by the number I'm with, times by the number I'm going to, so divided by 1 times by 2, which gives me 20 mole. So 20 mole of NH3 should form here. Okay, and if they ask me for the mass of NH3, I'd easily just work with the mole triangle and work that out. We'll do that in the next one. Okay, so important here is we're going to start giving you incorrect amounts of certain substances, and you have to figure out, first of all, which one's incorrect, and then you don't work with that one when it comes to working out the product. Okay, let's do another one exactly like this, just with different values. Okay, we'll stick to that same reaction. Okay, and sometimes it's quite easy to see which one is incorrect, and sometimes you have to work it out. Regardless, you have to show you're working. So if you can see it, it's just a bonus. You still have to show you're working. Okay, so I like to rule off, and I like to distinguish between the top row being what I'm actually given, okay, what I'm physically given, and then at the bottom, I work out how much I need. Okay, so I call that the needed row. Okay, so let's say you were given 5 mole of this, and you were given 12 mole of H2, and once again, I ask you to work out how much product is formed. Okay, I'm going to do this one with you again, and then the next one you can do by yourself. So, start whichever one you want with, okay? If I have 5 moles of this, how many moles of this do I need? So I can just do a little quick calculation in my head. So 5 divided by 1 times by 3, 15 mole. So I've got a bit of a problem. I wasn't given over 15, I was only given 12 mole. Okay, but let's write that down. 5 mole divided by 1 times by 3, which gives me 15 mole. Now just be careful to distinguish between what was actually physically given to you and how much do you need in theory. So I was given 12 mole, but I need 15. So then your question to yourself becomes, was I given too much or too little of the substance? Now in this case, for hydrogen, I was given too little. I was given only 12 moles and I need 15 moles. So that one is called the limiting reagent. Okay, the one that you're given too little of is called the limiting reagent. Now let's work the other way. Now it doesn't matter which one you start with, by the way. You can go 12 and then work your way towards this side, or you can go 5 and work. I just do both in any case. Whether they ask me to work out the excess or the limiting, I just show both. No one's going to penalize you for that. So let's say we have 12 moles here. So 12 mole, 12 mole here. and we say divided by 3 multiplied by 1. Okay, then we get 4 mole here. Okay, so if I had 12 mole of H2, I need 4 mole of this. Now, compare the values. You were given 5 moles of this, but you need only 4 mole. Were you given too much or too little of the substance? Well, if I only need 4 mole, I was given too much. And that makes this one the excess. Okay, that one's basically the incorrect one. It's the one that I'm giving you too much of. So in the recipe analogy, this is the flour and the milk. You're given too much of that compared to the eggs. So take a highlighter and highlight your limiting reagent. And it's always the given that you highlight. Remember, because you don't really have 15 mole. It's a theoretical value that you needed if you were given 5 moles of that, or you were given 5 moles. So you always highlight the given limiting reagent. Okay. Now the question is to work out how much product I form. So I always use the given of the limiting reagent. So I go 12 mole. Okay, again, use colors and things here to help yourself. Divided by 3, because I'm going from the hydrogen to the ammonia. So divided by 3, multiplied by 2. Okay, so divided by 3 gives me 4, multiplied by 2 gives me 8 mole of NH3. So that's how many moles of NH3 would form if I gave you 12 moles of H2. So what's essentially going to happen here? Let's add a little extra question to this. What's essentially going to happen if you give something that's an excess, you're being wasteful. So one of the questions they could ask is, how much of the excess is left behind in the container at the end of the reaction? So you go, oh, okay, so you make your own little formula. Okay, let's just squish this a bit so we can fit this in. So 4 mole, this is my excess. So then I write my own little formula. There isn't a mark for this formula, so it's really just for yourself. So then you go, okay, the extra or the excess is the given minus the needed. Okay, so what you're given minus what you need. So I was given 5 mole of the N2. I only need 4 mole in this reaction. That leaves me with an excess of 1 mole of the N2. Okay, then they could obviously ask you work out the mass that's an excess. And again, that's very easy. You would just go the mole triangle for mass is moles times molar mass. So 1 mole times the molar mass of diatomic nitrogen is 28. So you'd say, look, at the end of the day, you'll be wasting 28 grams of nitrogen. 28 grams of nitrogen will be left over in the container when this reaction is finished. So when this reaction is finished, you'll have 8 moles of NH3, which is however many grams, plus you'll also have this in the container, the excess amount. Okay, and obviously just the extra, not all of it. Some of it's going to go to waste. The 4 moles is